Wonderful. Why don't I get started? Where is my screen? There it is. Perfect. So for those of you who just joined, as I was saying, I'm kind of testing out this new setup. And as this presentation started, I realized that it's great to present because I've got my camera in front of me, but my chat windows are on each side of me. So whenever I'm looking on the sides, because I'm kind of trying to get a glance at you people or at the chat to see what's going on. Anyway, so this being said, I will try to monitor those chat windows. If you have any questions or comments along the way, be happy to answer them. All right, so let's get started with our presentation. Node.js, machine learning, Kubernetes, and unethical face recognition. So basically, I was trying to get accepted as many conferences as possible. So I tried to put as many buzzwords in my presentation title. I guess it kind of worked because it got accepted. No, seriously though. I was chatting with some of my friends, and I do a lot of conference, and I'll get back to that, or I used to in-person events, and we were kind of just kidding around and just talking about how great conferences are, how great it is to meet people and have great conversation with people. But sometimes the conversations, are not as great. You'll meet people that are I'm not sure how to say it politely, but anyways, some conversation that you could avoid. So I was trying to think, is there a way where I could use some open source technologies to be able to rate people and know if I should have a conversation with them or not prior to having the conversation, so I wouldn't lose any time? All right. So before you come out with with torches and pitchforks, that's absolutely the worst idea, and I would never do such a thing. I was kind of with a bunch of friends. We were kind of messing around, having fun, but it turns out that I was like, I wonder if I can do something about that. Like, it would be fun, wouldn't it? So that's kind of the unethical part of the talk, and I'll come back to that. But it turns out that you can go pretty far with just some open source tooling and some public data sources. So I'm going to show you how I built this application, how it kind of works. It's almost there, but I didn't want to push it too far either. And then I'm going to discuss a little bit, just a minute or two, about why you probably shouldn't build such a thing. So without further ado, let's get started. So first of all, hi, my name is Joel. Let me introduce myself. I am a developer advocate for Red Hat OpenShift. So as I mentioned, as a developer advocate, a good part of my job up until last year was to attend conferences, to go to conferences and meet software developers just like you in the wild, and have discussions about cloud technology, cloud platforms, and how do you deploy your own applications. So I mostly work for the OpenShift platform, which is Red Hat's Kubernetes distribution. And yeah, so that's kind of what I do. And that's why I tend to travel a lot, and I tend to meet a lot of people at conferences. I am based in Canada, lovely Canada. It is minus 20 degrees this morning, kind of snowy. I wish I was in London, but hey, it is what it is. Love this place. I'm just not used to spend the full winter here. I'm also French Canadian, so that's the charming little accent that you might have noticed there. And I love Twitter. So if you ever want to get in touch with me, Twitter is always the best way. Anyways, Joel __. So there's 2 underscores there. Joel __ Lord is where you can find me on Twitter. I will be doing some little things with Twitter in a few minutes. So if you want to participate, you might want to follow that account, and feel free to just unfollow afterwards. So yeah, Joel __ Lord, always the best way to reach me if you ever have any questions about Kubernetes, containerization, unethical face recognition. Feel free to reach out to me. I'll be more than happy to answer any questions or comments that you might have. All right, so let's talk about the application that I wanted to build. So I had this idea. I wanted to build an application that would rate people, right? I want to score people to judge them. So what I needed to do that was to find some sort of public data source. So I needed a lot of data, and I needed to be public, right? So I was trying to find a way to detect faces and to be able to score people based on things. I wasn't sure what at that point, but that's kind of what I needed. And then eventually I needed to deploy all of that stuff. And originally, when I came up with this idea of this application, I thought the whole face recognition would be a lot of fun to do. Well, it was actually a little bit harder than I thought originally. Um, but yeah, I thought that would be the fun part. It turns out that deploying this application was really, really fun, and I'll focus a little bit on that towards the end. I'll discuss how I managed to get everything up and running. So the first thing I needed was some sort of a public data source. So where can I find data? I wanted some data about people. I wanted to have, their face, so I could do some face recognition on that, as well as potentially maybe some sort of social ranking that I could give them, and to kind of have some sort of a feeling of what kind of person they are. And like there's why would people put that kind of information on the web? And where could I find that information? I was like, okay, well, that's not going to work because there's no way people will just give away all of that information. Turns out that Twitter is exactly that. That's what Twitter does. So it's a great source of public data. So people, most people will put up their profile image, and so we have a picture. So we have some face recognition that we can do right away. We've got sentiment. We can kind of see how people are feeling and how they're generally acting on the web through Twitter. We can get some sort of social data and scoring based on the number of followers they have, who they follow, and so on. So there's a lot of information that you can get out of Twitter, surprisingly a lot. For an avid Twitter user as I am, it's kind of a little scary, actually. But most importantly, and the greatest part is that they actually have an API, an API that everybody can access. So you can get all of that information relatively easily. So I wanted to build my application using JavaScript. I've been a JavaScript developer for years now. I love both front end, back end. So I wanted to use NodeJS to do that. So the first thing, and of course, as Node.js developers, what do? We just glue together a bunch of NPM libraries, right? So the first library I needed was Twitter. So npm install -- save Twitter, and that gave me access to a wrapper around the Twitter API. Makes it a little bit easier to access the actual API. So Twitter's API is nice. It provides you with a lot of data, but it's not the easiest to use. And there's a few reasons for that. The main reason being that the API was designed when they originally built Twitter, and there's a lot of things that changed throughout the years. So things like we have followers, and you see here mentions of followers, and that kind of works, but there's how they're called again. I forgot how they call but I think it's usernames, but now we call them handles. And there's a few things that kind of change in the usage of how we normally speak about Twitter. But the API refers to kind of an older syntax. Statuses, that's the thing. So whenever they refer to statuses, that's actually a tweet. So that was kind of a few things that are a little bit tricky when you start playing around with the API. Nonetheless, it's actually relatively easy, so you can get your free API keys, just provide them to the library, and then you have access to a REST API, so you can get different things like the list of followers and so on. Now, the API is rate limited, so you'll have to, I think it's about 1 per second for most calls. You'll have to read the documentation, but you can't just send in a bunch of calls. Or quickly you'll end up through your rate limit. And one of the things is that they also return only little packets of data. So if you ask for your list of followers, they'll send in all the information about your followers, but only 200 followers at a time. So it'll provide you with a cursor so you can fetch the next series and so on. But you can't just follow or download 2,000 followers at once. So that is also one of the limitations that you have to keep in mind. Makes it a little bit tricky to build your APIs, but I still managed to do some things around that. So what I managed to do was to just fetch the list of followers. And now that I have all the IDs, and that one will return just the ID, so it'll actually return 2,000 IDs at once. And then I can actually put a stream, and I can do something like using a stream for the statuses or the tweets. So by doing something like that, and I'm using as a filter the IDs of my followers. Now, if you don't put in a filter you will get a lot of data. Like literally, you will get well, all the tweets, all of them, and it's a lot. So so your laptop will start to overheat, and your router will probably melt. So there's a lot of data that comes in. So you kind of need filters. So like I said, in here, I'm using a filter on my followers and just everything that has to do with them. And whenever there's a tweet that comes in, well, I can do some various things. So that's what I tried to do, just exploring with the API at first. And this is actually connected to the API. So anybody that is one of my follower or connected to one of my follower or retweets one of my followers. So pretty much all the tweets that are related to my followers in some shape or form at the moment are displayed in real time on the screen on my slide. So hopefully there are some people from NDC that are kind of following. That will definitely, at least Twitter is relatively active right now. So I did give this talk a few times very early when I was doing presentations in Europe while still in here. And a lot of my followers are North America based. So it was quiet. So at least we have some stuff going on right now. That's good. So you can see some of the information, some tweets coming in. So I'm now able to get some stuff. I have, you can see here, Kara, so I have her face. I can take that image and extract some data from it. I can also get the information from the tweets, of course, and try to use that and try to do some sort of analysis on that information. All right, let's move on. So Twitter. Okay, good. So I've got your face. I've got your tweets. So already I got a lot of information about you. Now what? What can I do with that? Well, now's the time to rate the people, right? That was my ultimate goal. And once again, if you just join, I'll come back to the unethical part of that. So don't panic right now. But my goal was to rate people. So how will I do that? So are you worthy of my time? Of course. So I'll have to think of a way to actually be able to judge you. That was very important for me. So first of all, you have to be one of my followers because I can't follow all of Twitter. That would be a little bit too much. And two, it's nice if you're one of my followers. You kind of know a little bit about my interests already, so we can kind of it makes it easier to have a conversation, right? So that's good. So that's the first criteria. For then you need some sort of following, right? I'll check if you have a decent amount of followers, because if you don't, it's probably not worthy of my time. So, so that's very important. You must follow other people as well, because you kind of need some sort of a wider range of opinion. If you just follow one or two people, that's you'll be a little bit too narrow-minded. Is what I used as a criteria here. And mostly, one of the things that is very important to me is to have positive conversations. So I wanted to make sure that your tweets are generally overall positive. So that was my criteria. That's what I used to be able to score you and to judge you. All right. So what I used to do that, machine learning. I think that's the best image to describe machine learning ever. I just love that image. So machine learning is what I will use for that. So I had big plans. I was okay, so I'm going to use a lot of machine learning and going to start training some models, do a lot of things. So machine learning is the study of computer algorithms that improve automatically through experience. It is seen as a subset of artificial intelligence. Machine learning algorithm build a mathematical model based on some sample data known as training data in order to make predictions or decisions without explicitly being told to do so. So that sounds good. That sounds like exactly what I need. So I started looking into building my own models. So I used TensorFlow. That was the first. That's the library that everybody uses. There's a version available for JavaScript or for Node.js, and it is not easy to use. So it turns out that you actually need to know what you're doing when you're doing machine learning. And I didn't want to spend that much time building my application. So I started looking into machine learning, how to build models, and there's a lot of maths involved. And basically, you've got to take some data, convert that into a mathematical model of some sort, and then based on that data, you can kind of extract and create a neural network where you'll be able to map some data points, and eventually the computer will give you a result. But it turns out that, well, it is kind of hard to do. There's a lot of things that can help you. TensorFlow is a great tool for that. And there's also a lot of cloud providers that will give you access to resources to actually train that model. But it is kind of expensive, so you'll have to spin up a little bit of, or take out a little bit of money, and it is still not the easiest way. I recently seen a talk on Redis AI, Redis Labs AI. I can't remember how it's called. It seems like they have an actual very interesting way to do that through their API. You can actually train a model. It seemed relatively easy. I haven't tried it yet, but just using TensorFlow, you kind of need to know what you're doing. So I didn't want to go through the hassle of learning all of that. And what I wanted to do is face recognition. And that's a problem that's been solved a long time ago. So there's no reason for you to actually go ahead and train a new model if there's something that already exists out there. So pre-trained models are available. And it turns out that there's a library, of course, in JavaScript, because you can just npm install everything. So there's a library that actually exists that provides you with some models, pre-trained with some models, and it will help you to do a lot of things with face recognition and face detection. It's called faceapi.js. That's the link. I'll provide you with all the links at the end. So that's the first thing. So face detection is the first thing that I wanted to do. So can I check if there's a face in an image? So let's try to do that right away. So I've got, so the first thing I wanted to do is just see just a neutral image, and there it is. All right, so I can detect my face. That's good. Let me just make that a little bit bigger. There you go. Okay, so I can detect my face. That's good. Of course, that was kind of an easy one. So let's see if I can do something a little bit more tricky. So I kind of went and tried to hide in a corner, and that still works. And then I tried another one. And there you go. So 98%, like that was very good. And I'm kind of hiding in the corner. So I was kind of impressed with the results that I got from that immediately. So as I kind of started to explore that, I tried to see what else can I do with this library. And another interesting thing that it does is face landmarks. So as you can see here, it actually takes 68 different points in your face and tries to identify all of those. So the face landmarks are very important because that is what ultimately will be used for face recognition. So basically, face recognition uses those 68 points in your face, and based on the ratios between all of those it kind of tries to flip the image, try to put it in the center, and so on. And then based on the ratios, it tries to identify if your face is the same one as some data that you already have. So this is the one that I've used. And once again, if we go back to the other images that I had, you can kind of see that it works really well. It maps all of those different points. Now, with Face API, there's a few models that come pre-trained for you. So you can use various models to actually use that data. For the face detection, I'm using the SSD mobile net, I think, model, and it's a common one that you can use that is available open source. It is a little bit slow to do face detection, so you might have noticed the first one, but actually the model was preloaded as soon as I opened up my slides. But even there, you might have noticed that it took like kind of a second before it was able to detect my face on the first image. Now that it's loaded, it goes a little bit faster, but it does take that little second there. If you want to do real time, if you want to use a video, you can also use the exact same library on a video, because basically what I'm doing here is that I'm taking a file from the file system, putting that into a canvas, and then doing the detection on the canvas. So nothing prevents you from doing that with a video. You just put the image on the canvas and then do that recognition, but you'll need something a little bit faster. So there's another model called Tiny Model, and I'll show you the difference between the two in just a few seconds. All right, so face landmarks, that works. I can do some fun stuff with that. What else can I do? Face expressions. That was just a fun one that I realized that I can do with this library. So we can see here that this face is, well, kind of neutral, which makes sense because I was just trying to do something neutral. And when I was hiding in the corner, well, still kind of neutral. Not sure about that. Let's try other stuff. This one was a little bit confusing for our model here. A little bit of surprise, neutral, disgusted. And let's see, what else do I have here? This one, angry and surprised. So I can kind of do some various things and detect some face expressions. What else do I have here? That one was pretty good, actually. Angry. I think it kind of looks angry. So that's good. I can do face detection, face landmarks, face expression. I ended up not using face expression because that was maybe a little bit overkill for just a demo app, but I thought it was a fun one to explore. All right, how to use a Face API. So basically, you just import the library. It's a Node module, once again. You can use it in Node.js or in your browser, so whatever is more convenient for you. And once you have loaded, so what I did here was to take a file from the file system, and basically I just rendered that inside an image tag. Oops, an image right here. So just take the data from the file system and put it in the image as an image source. Once I have that image, and then it's the time to load my models. So as you can see here, I'm using the SSD Mobile Net V1 model to detect the faces in the image. And I'm also loading the Face Landmark 68 Net model to detect the face landmarks. If you want to do face expressions as well, you'll need to load an additional model, which is called conveniently face expressions. So you can just load that model from the disk. It comes with the Node.js library or the Face API library, so you can just use them out of the box. Good. So now what I do is that I take that image and basically just put it into a canvas. So I just copy or draw that image from my image tag into the canvas. And from there, I can do some operations with Face API, such as detect all faces. So I can detect all the faces in an image, detect with the face landmarks and with the face descriptors. So the face descriptors are kind of those ratios that we're going to use eventually for face recognition. It also has a few nice little utilities, such as draw detections. So you can directly tell Face API to draw some stuff on the canvas. So those little square boxes around the face were just done automatically through Face API. So it makes it much easier to do such things such as drawing onto a canvas. If you're using Node.js, it is exactly the same syntax, so you can use it exactly the same way. But the only difference is that you will need to monkey patch with a Node canvas instead. So you'll need to import Node canvas, and then you'll be able to just use the canvas from Node canvas inside your Face API, and you're able to use it exactly the same way as you would with an actual canvas inside the browser. So very convenient, exactly the same code you can reuse at multiple places. So the code that I'm using in my slide here is actually the exact same code as I'm using in my Node.js backend. All right, so now you need to give it some sort of training data. So you can capture some training data as well. So you can just load image, load all the face descriptors. So those are all the points that you'll need. And once you have all of those, you'll be able to start, you'll have some training data that you'll be able to use for face recognition. So since we're talking about face recognition, so what about face recognition, right? So what I've shown you so far is detection. It can be useful for many different things, but not for our case. What we want to do is to be able to recognize people. So what about face recognition? Well, with the same library, we can train with some data. So right here, I'm training it with one image. And I can take one of my images that I had before and test it out, and it detects that it's Joel. All right, if you're clever, you might have noticed that I'm kind of cheating here because, well, it's the same image for both. So it kind of makes sense that it detected it. So let's try with another image. So that one in the corner still works, still detects my face. So it still identifies it as myself. Even with those, there you go. So it still detects at 0.47. So the lower the score, the better it is. So it actually can detect. So I'm using 1 point here, one image, and I can actually detect my face there. What about something completely different? So those were all taken in a controlled environment, right? So I took an image just a picture that I had with my beautiful wife here at the CN Tower. And I thought that was an interesting picture because it's a very different perspective, but it turns out that still detects me in a completely different context. Pretty cool, eh? Or kind of scary, depending on how you want to see it. But here, who's that? We don't know yet. So let's try to add more training data So I'll add a few more images of myself just to make sure that we can detect it. And let's try to add one image of my wife with sunglasses in this case. Let's try to get that picture again. And there it is. So Natasha, there you go. So we can actually identify her in the picture now. So we can identify two people in the same picture with pretty good accuracy, actually, surprisingly good accuracy based on 1 point of data. And if I add more images, then we can try again, and it should be a little bit more accurate even. There it is, and 52. So I can't remember what it was. I think it was 56 first. But so we can see that it actually is able to detect. So how do you do face recognition? So still using the same library, basically what you're using is a face matcher. It's an object that is available as part of the library. And what you'll do basically is that you will do a face detection. You will take all of those landmarks, take all of those face descriptors, and you'll create a collection of face descriptors with a label. So I'll say, well, Joel, the label Joel has those 3 images with the face descriptors. And then I'll use the face matcher to just tell Face API, look for all the faces in this picture and try to find the best match in the face descriptor library or object that you already have. So that's what I'm doing here, and it kind of works. So if you want to play around with Face API, there's this library Face API playground that is available to you. You can explore with it. They do some fun stuff with the Big Bang Theory characters. And you saw here, it loaded the SSD MobileNet V1 model. And you saw how it took a few seconds to load the model. And there was a little bit of a wait time there. But you saw it, and you can see that it detects the faces pretty accurately. What's interesting about it is that I can actually go and change another model. And I was talking about that earlier. So I said there's another model, Tiny Face Detector, which is blazing fast, but not as accurate. So if we switch to that model, we can see that it goes much faster, but the face detection is not as good. So it's a little bit larger, smaller in this case. That one is 79%, which kind of makes sense, but this one is not even detected. So there's different models. Explore, try what experiment, and you'll see, and you'll eventually find what you need. They do a lot of fun stuff in here, like video tracking. So you should see the face detection going on and so on. So it all uses the same code as I've shown, relatively easy to use. At first, it's a little bit complex. It'll take a few minutes, but once you have it and once it works, it's actually a very interesting tool to use. What's really cool about it is that it does face recognition with a single reference point. That's the one thing that I wanted with my model, right? So now, assuming that your Twitter profile image is an actual picture of you, and if it should be able to recognize you. So now, not everybody has a picture of themselves as their Twitter profile. Which by the end of this talk, you'll probably think that's a good idea. So that's why it doesn't always work with my demos. And if people wear a mask, a lot of people wear a mask on their profile pictures nowadays. And you probably should in real life, but so that won't work because you're blocking too much of your face. And while this library is pretty good, you saw how it worked even with sunglasses, but it won't work if you're actually wearing a mask on your Twitter profile picture. Still, I was mind blown when I saw that. That is so fun. There's so much fun and so much things that you can do. And the fact that it takes one single data point really blew my mind. All right, so more machine learning. So I wanted to do more stuff in here. One thing that was very important for me was sentiment analysis. I wanted to make sure that your tweets are generally positive. So how can you do that? You can use sentiment analysis. Sentiment analysis is the process of I can never say that word, of determining whether a piece of writing is positive, negative, or neutral. Sentiment analysis helps data analysts within large enterprises gauge public opinion, conduct nuanced market research, monitor brand, product reputation, and so on. So basically, you can just take a random sentence and you will score it. So it uses a pre-trained model, once again, with some score based on the words that are in the sentence. It also uses emojis and a bunch of different things. Of course, there's a library for that on Node.js, so you can use sentiment, just require npm install sentiment, require it, create a new sentiment object, and then you have access to the analyze method, which will return you a score based on the sentence. Then you take the average out of the number of words there are, and it gives you a score between +5 and -5. So let's take a look at our Twitter again, so we can see that that first tweet that came in. Well, that one was relatively neutral, right? It's just a link. You might notice that one has a little haze of green in it. It is score 0.09, so it is kind of positive. I'm not sure. Well, I guess cute. Cute is the word that was probably positive in there. There we go. We've got another one here that is a little bit more positive. So 0.23. So that's interesting. Let's see what looks positive in here. Ultimate might be a positive word. Not sure. So let's wait and see if we can get something else that comes in. Last time I gave this talk, it was kind of interesting. Oh, let's see if we have new followers. Maybe I'll refresh here. Let's see if this worked. There it is. That should work. All right. I know I've got one new follower. There we go. So maybe that one follower just tweeted or will tweet. We'll see. Last time I ran this demo, one of my colleagues sent like the worst hate tweet that I ever read, and it was like big red right in the middle of my presentation. Kind of funny. Anyways, so we can see here based on emojis. So this one from Nader, fire, fire, fire. That kind of sounds positive, so it scored a much higher. This one, did you ever SVN or CVS is relatively, oh no, that's a 0. So we can see how we can do some sentiment analysis. I was worried for a minute that CVS might be seen as negative. So, all right. So we can see how we can now score some of those tweets. So what do I have so far? I've got some public data. I've got some faces. I've got some tweets. I've got a lot of information. Now comes the time to connect everything. And as I mentioned at the beginning, I thought the fun part would be the face recognition. Turns out it was kind of fun, and I love talking about it. But connecting everything was maybe not as glamour, not as demoable, but it was really fun to actually figure out how to connect all of my things together. So I had all those little samples. I was able to, I had a small sample to do face recognition. I had another code snippet that did my sentiment analysis. And I had another code snippet that fetched some data from Twitter. But I needed a way to connect all of those together. I didn't want to write this big application. Like I had all those samples that I managed to get working and with duct tape and tie wraps, but it was working. So I didn't want to rewrite the whole thing at this point. So I thought, why don't I just take those and create a bunch of microservices and then connect all of those together. So the first thing, microservices. So that was actually perfect for this application. So it turns out that it was my first real experience with a bunch of microservices. So I worked with, decoupled system, but really tiny microservices, and it worked out to be great. So I did use containers. If you're not familiar with containers, there's a talk by yours truly called Containerization for Software Developers. Once again, I'll provide the link at the end. Also, I should probably talk about or promote it, but I've just published a course yesterday on Egghead about containers. So if you're interested in building containers for Node.js applications, take a look at the link. It'll be shared at the end. So container basically very quickly is a standardized unit of software that packages up code, all of its dependencies, so the application runs quickly, reliably from one computing environment to another. So basically, you can imagine a container being a giant zip file that contains your source code, of course, but also all the runtimes, all the configurations that are needed. So if you have a Node.js that you want to deploy, you will package up all of your JavaScript files, but you will also package up NPM, and you'll package up Node.js, and you'll package up basically a version of Linux that has all of those dependencies or runtimes installed, and that's what you will ship. So by using a container like that, you make sure that the environment is very, very reliable. You don't have those issues where you're trying to deploy something on a server that runs Node 8 because they never upgraded, or any of those problems. So it really makes it a lot more reliable to send those units. It is also a disposable unit, so that's very important to keep in mind. Once it is completed, it destroys itself along with all dependencies. So if you have a database, for example, that runs in a container, once you stop that container, it will destroy all the information. So that can be good, and that could be great for things such as testing, because it just, you can put in as much garbage in your database and you just destroy it once you're done and you start from scratch next time. But when you're trying to save that data, not as convenient. So you'll need a few tricks to help you with that. When running locally, you can mount a local volume with the data, but that's, or you can use things such as Kubernetes, which is what I've used here. So to use a container, Docker run is the way to start those containers. And yeah, you can just map some port, call your image, and off it goes. It is ready to run. You can create your own images. So you can use an image such as node 14, where was it? Right here, or node 12 in this case. Or you can create your own by using a Docker file. And that will create your own image that you can then deploy on servers. So you can build that image and push it to a repository or registry. So now that I had all those microservices, I needed a way for them to communicate to each other. And my first reflex was to use a REST API. For each one of those services, I wanted to use a REST API, but it quickly became really complex. And I was trying to figure out, like, okay, well, maybe I could use some sort of way, instead of using REST APIs, for them to communicate through a central point. And I was trying to build one REST APIs where all the other services would, send requests, and that was even worse. And it turns out that I had heard about one of those things called messaging queues, and I had never used one yet. So messaging queue is a form of asynchronous service-to-service communication used in serverless and microservices architecture. Sounds like what I need. Messages are stored in a queue until they're processed and deleted. Each message is processed only once by a single consumer. Message queues can be used to decouple heavyweight processing to buffer or batch work and smooth spiky workloads. Hey, that sounds exactly like what I need. So I've dig a little bit into it. I've looked at RabbitMQ, which is an open source project. And this is what it looks like. So a messaging queue, basically, you've got a publisher and a consumer, and your publisher will just send some messages in a queue, and your consumer will just take them whenever it's ready to pick a message, and the queue will build up so you never lose any of those messages. You can also have competing consumers. So you can have more than one consumer that will extract those messages. And that was very convenient because I had a first publisher that took some information from Twitter. It took out hundreds of Twitter followers. And then I needed to convert that information into something that I could actually use. So I sent those to a queue for one of my consumers that would transform that data into something useful. And that was very quick. So as soon as one got in, it got out immediately, transformed that and sent that into another queue for the image to be analyzed. But that process was a lot longer. So analyzing the image, while the transformation took like fractions of milliseconds, getting the image information, that one took about a second. So that queue built up really, really quickly, and it quickly became into 1,000. So I wanted to extract that information a little bit quicker. So I've just used 2 microservices, 2 containers to actually process that data a little bit quicker. Actually, I ended up using a few more, but you see the point here. Because I had REST APIs in mind, I was really looking into a way to send a message and get a response back. So there is a request reply pattern that is available in messaging queues, but it turns out that it's kind of an anti-pattern. You probably shouldn't use it, and it turns out that I really didn't need it. So simple pub sub just required a library, that will connect to your server, and then you create a channel and just send messages to the queue. So very, very simple to use. And for the consumer, very similar. So you just create that channel once again. You assert the queue, make sure it has all the requirements that you need, and then you have a stream. So you just consume. So whenever you receive a message inside the queue, you can actually process that message and do something about it. So RabbitMQ, they have a great getting started guide. I'm starting to go faster. I see that I'm running low on time. All right, so now is the time to deploy everything. So I had all of those microservices. I had a messaging queue. Everything was communicated through that messaging queue. And so whenever I would receive a tweet, I would send that information to my transformer process and would transform that into something that I would be able to use. It would then send a message to the database with the new transform tweet or transform profile. That database would save it somewhere, so I wouldn't have to, do that whole fetching every time. It would check for profile pictures. If it found one, it sent that message to another queue, and so on. So all of those microservices, and I'll show you a diagram with all of them in a few seconds. So now is the time to deploy all the things. Kubernetes is what I've used. If you ever need to learn about Kubernetes, there's another link that I'll share at the end called Kubernetes Kitchen, where I kind of explain what is Kubernetes. In a nutshell, it's an open source system for automating deployment, scaling, and management of containerized applications. Basically, what it does, Kubernetes, is that it will make sure that all of your containers are running at any given time. So if it sees that one of your containers stopped, it will just start a new one. If you need to scale it up because you've got a good amount of data coming in and you need to process it a little bit faster, just like I've shown you earlier, well, you can easily scale it up. And most importantly, it takes care of all the networking between all of your different containers. So it takes care of all of that for you, so you don't have to worry about any of it. It uses pods, deployments, and services in order to create that architecture. This is kind of what a deployment looks like. So basically, you take a YAML file, you describe exactly what you want. How do you want your containers or your pods to be deployed? A pod is a collection of containers that are tightly connected. Typically, you would only use one container inside a pod. You'll have edge cases where you can use more than one. So this is a deployment. So in this case, I'm saying, well, I want 3 replicas of this pod here, or this container that will run on port 3000, and it will use the image that I've created earlier. All right, so now I have my services. A service is a way to expose those pods to the internally at first. So in this case, I'm just telling Kubernetes, well, look for all of my components called queue. And those are my RabbitMQ servers. And then just expose them internally. Just expose those internally as RabbitMQ on the port 5672, which is the default port for RabbitMQ. What this will let me do is that now, instead of calling localhost 5672 like I do on my local system during my environment, during my development environment, I can actually use the name RabbitMQ and send requests directly to it. So it's a lot easier. So everything can be found inside the system. So if I had more than one RabbitMQ server, it would do some load balancing throughout them, and so on. So all of that comes for free, basically, out of the box with Kubernetes. So this is what I had. So in this case, I've used OpenShift as my Kubernetes distribution. Of course, they pay me to be here, so I'm gonna, promote them. But a nice thing about OpenShift is that they provide you with this UI, so you can really see what is in your system and how it kind of works. So you can see here that I have a Twitter right here. So Twitter is listening for new tweets. If it detects a new tweet or a new follower, it will send a request or send a message to my RabbitMQ here. If it detects a new follower, it will send a message to my transformer. Transformer will process that data, transform it into something that I want in my database, send a message back to RabbitMQ, which will then send a message to, where's my server here? My server will pick that data, update my database as needed, and then send a message. If it detects that there's a new face, for example, a new profile picture, it will send a message to RabbitMQ, which will send it to our face processor here, which will then extract the image information, and so on. So you can see how they're all connected. There's my sentiment analysis here, my one service to score the people based on all the information that I got. So if there's a new picture, well, I'll try to, or if there's a new tweet, I'll do a sentiment analysis, send that to my scoring. So everything is managed and everything communicates through a single point, which is my RabbitMQ right here. All right, so last thing we've got, I'm not sure if we're gonna be able to do a live demo, but I've got here my my application running on my tab that is put up to sleep. And so I had all of that information. Now let's see if it actually works. So I took a picture with one of the last conferences where I was at, which was actually in Denmark. I can't remember who was from Denmark, but so I took this picture right here, and there it is. So those are some of my people that I've met at the conference, or some of my friends. And let's see how it got detected. So we see here, that's me, which was detected as Todd Albert. So okay, well, that's kind of deception. It didn't work as I expected, but it kind of makes sense, right? Because I'm looking for my followers, and I never actually look for for my own profile picture. So it kind of makes sense that this wasn't detected accurately, but that's too bad. This year is Jeremy, not Felix. So, well, okay, another disappointment here. It didn't work exact, but to be fair, Jeremy has a drawing of himself as his Twitter profile picture, so it kind of makes sense that it wouldn't be detected as being himself. This year is this is Aaron, so not Vincent. Even though Vincent is a great guy, that's not him. But once again, it kind of makes sense because Aaron has a mask on his Twitter profile picture. So okay, so I've got a good excuse for all of them, and it turns out, look at that, that is Bailey. So she got detected. That worked. That's perfect. That was great, and she was scored 16 out of 100. So based on this, I can accurately detect that I should not spend any time with Bailey anymore at any conference where I meet her. So, okay, so that brings us to the unethical machine learning part of my talk. So, and that's very important, and we've all heard about a lot of cases where machine learning was being used at various enterprises, and it has biases in them. And that's very, very important. We've probably heard about examples where some police detection system would tend to bias people of color and would treat them as criminal. The system would detect them as being more likely to be a criminal than a white person, and that was documented many times. There's a large enterprise that actually trained their model for automatically doing some filtering with the resumes that they got in. It's a large company. They received millions of resumes, so they wanted a way to immediately, based on machine learning, to filter out some resumes that would stand out. So they took their whole employee base, inputted all of their resumes inside the system, and took all of them that they rejected. And it turns out that the system, the machine learning algorithm, had a bias towards white men. Because most of their current employee base were white men, right? So you have to be really, really careful about the biases that you introduce into your system. And turns out that if I actually listen to my system here, I would never talk to Billy in my whenever I met her, because she was scored so low. But my scoring system, and then that was kind of deliberate, right? But it was so biased. It was incredibly biased, and in this case, I knew that I took some data, but you have to be really, really, really careful when you're using machine learning not to introduce any bias. Get a diverse team, get different opinions, get more people to look at what you're trying to do and what you're trying to accomplish, and make sure that you find those gray zones here. All right, so how much time do I have? All right, let me just share that link at the end, and I'll try to come back with, I'm not sure if anybody followed me on Twitter, so we'll see if that works. I'll try to get a screenshot of the faces that are on WebEx here. But just quickly, I'll leave you with a few links. Containerization for software developers, my talk, which I've mentioned, it will be linked. Kubernetes Kitchen, another talk about Kubernetes. RabbitMQ, great for messaging queues, and the Face API JS library. They have great documentation. So easyurl2/unethical is the one link where you'll find all the information. Thank you for being here. Stick around for another 2 minutes if you want to try it out. And if you're following me on Twitter, I need at least one follower on Twitter. And I'll try to take a screenshot of WebEx and see if we can do some face recognition with the people there. So thank you for attending. If you're not interested in those, take a break and go take a few minutes. Thank you for being here, and let's give that a try. So I've got my WebEx opened up. Actually, all right. Oh, too bad you're not on Twitter. Let's see if I can. All right. How can I do that? This is the first time I'm going to do this live, so I'm not sure how this is going to go. Let's try to put this here. Can I change the view to see more faces? All right, let's, Trying to see if there's a different view. I am not familiar with, stop sharing my screen. I'll start with that. I can still, there's just a tiny thumbnails. Participant, no, that's that screen here. All right, we'll still give it a try. So hopefully there's only 3 of you sharing your video. Still, let's try to get people, if they're attending. I suspect that there's always people at virtual events just putting it in the background, not listening. Choose layout, then grid. Where is layout? I mean, I suspect that there's a layout somewhere. I just don't see it. Top right. There's nothing in the top right. All right, let's try with the thumbnails. We'll see. That's probably not going to be good enough, but let's try to get a screenshot here. All right, so if you now's the chance to get your your 5 minutes of glory. So take a new screenshot. Let's try to get this in. All right, I'll try to just take a small piece here. I'll look at the camera. Okay, and screenshot taken. Let me share my screen again. If I can find that button again. I'm having a hard time with this application here. Okay. Oh yeah, I've got a screenshot. Let's, where is my screenshot? Oh. Should have probably organized this better beforehand. Home, pictures, screenshot. Where do I put my screenshots? Screenshots. All right, getting there. I'm getting there. Please bear with me. I know you're all so anxious. Oh, there it is. There it is. Okay. Okay. So now that I know where it is, let's try it. Choose file. Home, pictures, screenshots. Oh, what was it called now? I'm guessing it's that last one. Oh, where we've got one. We've got one. That's not bad. We've got 2. Bobby Cahill. No, that's definitely not Bobby. That's me. That's, or listen, I'm assuming that's not the right one either. Well, well, at least I've tried. I mean, it's not perfect, but
it's not my name, but I don't have Twitter, well, so.
Oh, well, there you go. So if nobody's on Twitter, no wonder it doesn't work. Okay. Well, with that, thank you so much for playing the game with me. I appreciate your that we've been able to at least give it a try. As I said, if you want to reach me, I'm on Twitter. So Joel__Lord. If not, easyurl2/unethical. You'll find my contact information there. Thank you very much for being here. Have a great day.